Dear students, greetings for the day. Today we will discuss about resolution of vectors and triangle of vectors. Vector is represented by a directed line segment having magnitude and direction. Vector is defined as the physical quantity which possesses both magnitude and direction and obey parallelogram law. We know that vectors are several types. The vectors which are having zero magnitude are known as null vectors or zero vectors. Vectors which are having some magnitude are known as proper vectors. Vectors having unit magnitude are known as unit vectors or modulus vectors. Vectors lying in the same direction are known as coplanar vectors. Vectors lying in the same plane are known as coplanar vectors. Vectors starting from the same initial point are called coinitial vectors. Vectors lying in the same direction, whatever may be their magnitudes, are known as like vectors. Vectors which are directed in the opposite sense to a given set of vectors are known as unlike vectors. Position vector means the vector which represents the position of a vector with respect to the origin. So a vector which specifies the position of a point with respect to origin is known as position vector. It specifies the position of the point P with respect to origin O. Now we know the result. We discussed about the resolution of vectors. Now consider a point P which is at a distance from origin O. Consider the vector, position vector OP bar. When we draw the projection from P to Q, that it cuts the x-axis at point Q, and when we draw projection to y-axis, that it cuts at R. Consider a vector A bar which is equal to OP bar let OP bar makes an angle theta with the horizontal axis OX. Now, from the figure, sin theta is equal to PQ by OP. is PQ is equal to R also, vertical component. So vertical component of P bar, let it be P bar H, and P bar vertical component, horizontal component P bar OQ. So P bar V by OP. OP means A bar. So from this vertical component is equal to modulus of A bar into sin theta. Similarly, in the figure, in the angle OPQ, cos theta is equal to OQ by OP, that is A bar H by modulus of A bar. From this, horizontal component is equal to modulus of A bar into cos theta. So these two expressions, A bar B, that is vertical component of A bar is modulus of A bar into sin theta, and horizontal component of vector A bar H is equal to modulus of A bar into cos theta, are known as the scalar components of a vector. Now let us do one problem on this part. A force of 200 a force of 200 Newton is inclined at an angle of a force of 200 Newton is inclined at an angle of 30 degrees to the horizontal. Find the components in horizontal and vertical directions. Solution. Here given that force F bar equal to 200 Newton, and theta is angle is 30 degrees with the horizontal. So here vertical component is given by f bar v is equal to f bar sin theta, that is 200 into sin 30 degrees, that equal to 200 into half, that is 100 Newton. And horizontal component is given by f bar h is equal to modulus of f bar into cos theta. From this 200 into cos 30 degrees, that is 200 into root 3 by 2, that is 100 root 3 Newton. Or 1.732 Newton. Into 100, that equal to 173.2 Newton. Let us discuss the resolution of vectors, second part. Vector components of consider a vector A bar consider a point P. OP bar is equal to OA bar. A bar. Now, vector components of a vector A bar is here. From figure, OP bar is equal to OM bar plus PM bar, that equal to OM plus So here, when we take projection from P, that's the x-axis item, then OM bar is equal to AX bar. It is called X component of A bar, and Y component of A bar is A bar Y. Therefore, magnitude of A bar is equal to AX square plus AY square. When we consider a vector in three-dimensional Cartesian coordinate system, XYZ axis, consider a vector A bar So here, when we consider point P, then OP bar is equal to A bar. And when we take the projections from P to XYZ axis by constructing Q as shown in the figure, then the component of A bar in the X direction is A bar X, and component of A bar in Y direction is A bar Y, and the component of A bar in Z direction is given by A bar Z O2 here, this point. Therefore, the vector can be written as the sum of three components in x, y, z directions respectively. In x direction component a bar x, y direction component a bar y, z direction component a bar z. Because in three-dimensional coordination system, the unit vector is I bar. Like when we consider the length meter in SI system, here in x direction, unit length is represented by I bar. So magnitude of I bar is equal to 1. Therefore, AX I bar can be written as modulus of A bar into I bar x. And A bar Y can be written as modulus of A bar into J bar. In this direction, J bar is the unit vector. In this direction, K bar is the unit vector. In Z direction, unit vector is K bar. Simply, this may be written as AX I bar AY J bar and AZ K bar also in some textbooks. So, in three-dimensional Cartesian coordinate system, vectors are resolved into three components in x, y, z directions. So, any vector can be written as sum of the three components in x, y, z directions, like ax bar plus ay bar plus az bar, which may be further written as modulus of a bar into I bar plus modulus of a bar into j bar plus z component may be written as modulus of a bar into k bar. Now, we know about unit vector. We already discussed that unit vector or modulus vector is a vector whose magnitude is equal to 1. So, here a bar x is equal to ax bar is the component of x component of a bar. So, this may be written as here a bar x is equal to modulus of a bar into unit vector in x direction. So from this unit vector is equal to unit vector I bar is equal to a bar x by modulus of a bar by, when we divide with its magnitude in x direction, then we obtain the unit vector of a bar. For example, if you find the unit vector unit vector is obtained by vector, whenever we divide a vector with its magnitude, here magnitude is 25. So this is the unit vector in x direction. If we consider the unit vector in x, if consider a vector which lying in the xy plane. For example, if we consider a vector 3i bar plus 4j bar, then here vector is 3i bar plus 4j bar. Now we dividing with its magnitude 3, 4 plus 4 square. Then that is so to find unit vector, we divide the vector with its magnitude, then we obtain the unit vector in the direction of the given vector. So in two-dimensional system, given vector a bar can be resoluted as axi bar plus ayj bar. In three-dimensional Cartesian coordinate system, any vector, for example, a bar is can be resoluted and can be written as a bar equal to axi bar plus ayj bar plus azk bar. Now we discuss about the addition of vectors. Suppose we want to add two vectors. Consider two vectors a bar and another vector b bar. Now we want to add these two vectors. To add vector pq bar to the vector qr bar. To add vector a bar to the vector b bar, first take the tail of p bar, join it to the head of a bar, and then join the tail of A bar with the head of the Q bar. Then we obtain the resultant. So resultant is equal to ER bar is equal to A bar plus B bar. Or if we place this one as resultant as C bar or R bar, C bar, then C bar equal to A bar plus B bar. So to add two vectors, we add the tail of the second vector to the head of the first vector and join the tail of the first vector with the head of the second vector. Then we obtain the resultant of the two vectors, that is PR bar or C bar equal to A bar plus B bar. If we to find the resultant of two vectors, we use triangle of vectors. If we do, know the angle between the two vectors acting at a point, then to find the resultant we use polygon law of vectors. First we know about triangle law of vectors. Consider two vectors or two forces acting at a point are represented in magnitude and direction. Then the resultant is represented in magnitude and direction by the third side or closing side of the triangle taken in the opposite order. So if here we consider two vectors, A bar and B bar. And second vector B bar, whose endpoints are Q and R. Now to obtain the resultant, join the tail of the A bar with the head of the second vector. Now the resultant, so first vector A bar is represented by the triangles one side, then B bar by the second side of the triangle, then the resultant is represented by the third side of the triangle taken in opposite direction. So when two vectors A bar and B bar are represented by the two adjacent sides of a triangle taken in an order, that is in anti-clockwise direction, then the resultant is represented by the third side taken in the reversed order. Resultant C bar or PR bar is equal to PQ, or simply A bar equal to A bar plus B bar. So resultant C bar equal to PR bar is equal to PQ plus QR, that equal to PR bar, or C bar may be written as A bar plus B bar. From this, since force is also a vector, there is alternate statement for parallelogram law of forces. If two forces acting at a point are represented by the two sides of a triangle taken in an order, then the resultant force is represented by the third side taken in the opposite direction. Triangle of forces may be stated like this. If two forces acting at a point are represented by the two adjacent sides of a triangle taken in an order, then the resultant is represented by the closing side of the triangle taken in the reversed order. Or it may be stated in another way also. If three forces acting at a point, are represented by the three forces by the three adjacent sides of a triangle taken in an order, that is in anti-clockwise direction. This also taken in this direction. Then the point O will be in the equilibrium. This is the another statement for triangle of forces. Now we discuss the application of triangle law of vectors. Crossing of a river. Consider a river flowing like this in this direction with velocity v bar. Now consider a boat lying on the one side of the bank, wants to travel to the exactly opposite point B. But as the river is flowing towards the right side with velocity v bar, then this boat should be pulled with the angle theta in the direction making like this. So resultant is AB bar. This is boat velocity. This is water velocity, river water velocity. So V bar W is represented here. V bar W, river water velocity. So resultant AB bar is obtained equal to AC bar plus AB bar. That is boat velocity plus river velocity. Consider the direction of the boat, which is mentioned in terms of the angle. So with the direction AB, that boat should be rowed in the direction making an angle theta. Then from the figure, triangle ACB, sin theta is equal to BC by RCB by AC, hypotenuse. CB means river water velocity, W by AC means boat velocity. Therefore, W is equal to, we want to, here, if we know the boat velocity and river water velocity, then we want to find in which direction boat should be rowed. That is, if we want to find the angle theta, then it is equal to sine inverse river water velocity by boat velocity. Now we shall do one problem on this formula. If we pull the boat river with a velocity of 10 meters, let's consider the river water flows at the velocity of 10 meters per second, to cross another bank. What boat velocity be 15 meters per second. Then the direction of the boat should be, for example, this is 4 meters per second, and theta is equal to sine inverse 4 by 15. This is equal to 15 degrees, 27 minutes, 58 minutes. Thank you. If you have any doubt,